B be a subset of a topological space. Okay. And now the set B dash of all limit points of B as a name is now called the derived set. Okay. So normally we represented B dash, isn't it? So that B dash is the set of all limit points. Another name for limit point is cluster point. Some call them limit points. Some call them cluster or accumulation points. Whichever you call them. Either call them limit points, cluster points, or accumulation points. It's all the same. Now this say if you collect all of them, you are going to form a set, and that set is called the derived set of B. Like I gave you example before. If you have a set like this, if this is your set B, this set is what? Often good. Because it doesn't have its boundary. Now, if you now create boundary for it, then you are going to call it B dash. This one is empty inside, contains only the boundary. So this set is called derived set. Derived of B. And these points that make up this boundary are called accumulation points or cluster points. These points that make up. Okay. In the example I gave you on closed sets, are limit points of set. Can we kill this? If my set is like this, okay. Supposing, let me use another letter. Let me say this is A. It's an open set. and I want to create the limit for it, then I will now say this boundary now, isn't it? These points that make up the boundary are now the limit points also, okay? They are what? Accumulation points. So this accumulation or cluster points or limit points. So in the example I gave you, if you pick any point on the boundary, if you pick only one of them and try to form a small open set, isn't it? Let me say it's even open. A small open set around this. What it means is that this point is going to contain some points inside. This is do I say A dash?
Yes.
I call it A dash. There are points inside A dash apart from, so suppose this is my Y. There are other points inside, you can see, isn't it? Or can I use another marker? Or can you see it? Maybe if I use this, I say this is a small open set. You notice I'm using round because I'm using neighborhood now. I'm using two-dimensional space. What I'm saying is that there are points inside this region which belongs to A dash apart from this Y. Is it clear? So it means, therefore, supposing this is my open set, I call it U. Then it means U intersection A, the set A, contains Y, isn't it? Also contains some point B. YIV is not empty. Apart from Y, it also contains some points. Or I can also say, for example, U intersection of if you intersect it with the A minus Y, okay? A minus Y, you are not going to get an empty set. Meaning that there are other points apart from Y in A, okay, which are actually in A as a result of these limit points. So that's what we call this one. So this point is called a limit point or a cluster point or an accumulation point. Is it clear? This example is in 2 dimensions. The other one I gave you with interval is in 1 dimension. This is 1 dimension. This is 2 dimensions. This is from straight line. This is from 2-dimensional space or R. Is it clear? But also you call this, normally we call this neighborhood, we call this interval. Okay, good. So we now know what limit points are, and we also know what the derived points are. Now these notions or these notations actually has equipped us actually they have equipped us to define closed sets more clearly. Is it clear? So we can now define a closed set. So a subset A of a topological space is called a closed set if and only if it contains all its limit points. If it doesn't contain some, it is not closed. Just imagine, supposing this set, like I said, set of limit point, this set is not, supposing it's not complete. Suppose this place is dash, dash, dash. It contains these ones, but it doesn't contain this. Then we are not going to call it a closed. If it has to be, if it is closed, it will have to contain all the limit points of it. So it's another definition of closed set there.